Generative process planning. Basically, there are two various approaches to plan a process in CAPP systems: generative, GCAPP, and variant, VCAPP. Differences are significant and are also reflected in models of manufacturing processes. An intermediate approach, also called a hybrid one, is also customary, but its description cannot be easily formalized. Generative planning consists of drawing up the process using individual features, to synthesis of tasks on an increasingly higher level, a complex operation, mounting, operation, processing stage, manufacturing process. The generative approach is used if manufactured machine parts significantly differ from each other and groups of parts with manufacturing similarities cannot be identified. The process model in GCAPP is generated gradually as progress is made in planning it. A generated model has a dispersed nature, however, it includes modules with a previously defined structure. It is then necessary to determine the number of modules of a certain type and classify them. Presents the general structure of such models. General, partial, multi-tool processing operation model. The Petri network language class used for building the model has the following form. Where P, a non-empty, finite set of places, T, a non-empty, finite, disjointed of P set of transitions, E, P times T, T times P, a flow relation, I, a set of inhibitor arcs, S, T and 0, a function of time, R, T, a priority function, and M0, P, 0, 1, an initial marking. The conditions of preparing transition to a firing have the following form. Where MP a current marking for place, *T transition input places set, IP, T, inhibitor arc from place to transition. 2. Applies in cases where only one transition meets the feasibility conditions. If two or more transitions meet the feasibility conditions, only one of them, the highest priority one, is completed. Other transitions are ranked in next iteration of the simulations process. The interdependence between M current status and M status directly resulting from it has been defined as follows. Where T transition output place is set. The aforementioned class is therefore a temporary Petri network with a binary marking function and inhibitor arcs. Inhibitor arcs make the model simpler, more transparent, therefore, easier to build and analyze. The suggested module structure allows for automation in generating the model. Modules for replacement of tools in the number of tools used for the process control the need to replace a tool. Topologically identical modules of control of calling the Workpiece Coordinate System, WCS, should be identified as the position required by the production process and the orientation of a processed object in a machine coordinate system. A module of complex operations is the core of the model. Each transition in the module calls a tool and WCS for the subsequent complex operation. A subsequent module is a sequence of operations conducted using the same tool and subsequent features. The modules is an area for structural optimization of the process by way of minimizing the number of tool changes. The model is supplemented by modules classifying simple operations for individual features. A marker on the last item of a module means ending processing of a given feature. The aforementioned issue of optimizing the structure of multi-tool production operations might be solved using two simple heuristics. Give preference to the tool that might currently process the largest possible number of areas and give preference to the tool that might currently complete all the operations that have been assigned to it. The suggested approach allows for a satisfying sequence of simple operations with a small number or iterations equal to the number of tools used. It is an optimal sequence in more than 95% cases. In order to appreciate the benefits of this method, one can compare it to the full browsing algorithm. The advantages of this method also include a very simple method of transferring its results in the form of an organized sequence of complex operations to a formal network model. The sequence of processing individual features might be conditional on their technological nature. An opportunity to automatically classify the conducted operations then requires initiating the optimizing procedure. A function of priorities assigned to each transition is used for this purpose. Example use of this method based on genetic algorithm is shown in the work.